So the title of my presentation is High Performance Computing at the University of Arizona, and high performance computing refers to supercomputers. So what is a supercomputer? So simply speaking, a supercomputer is an extremely large computer that is substantially faster than personal computers like laptops and desktops. So here I have two examples. The first one on the left is the Sierra supercomputer from Lawrence Livermore National Lab, and the second one is the Intrepid supercomputer from Argonne National Lab. So as you can see, these are quite big machines. The next question is what makes these supercomputers fast? So the answer is they have extremely large number of processors working in parallel. So most personal computers have only 4 to 8 processors, while supercomputers have thousands of processors. So for a given job, a personal computer will use 4 or 8 processors in parallel, while a supercomputer will use hundreds of thousands of processors in parallel to execute the same job. So, in simple words, a supercomputer has a much larger workforce than personal computers, which is what makes them substantially faster than personal computers. So, we have three supercomputers at the University of Arizona, and they are named Puma, Ocelot, and Elgato. Detailed technical specifications of these supercomputers is available on this website. So processors in these supercomputers are stored in the form of nodes, where each node is a collection of processors. So Elgato has 131 nodes, Ocelot has 400 nodes, and Puma has 236 nodes. And the number of processors per node is 16 for Elgato, 28 for Ocelot, and 94 for Puma. So for the same number of nodes, Puma employs the highest number of processors and therefore runs the fastest, and Elgato is the slowest. So the next question is how do we access these high performance computing resources? So you have to be in a research group. So every PI has a group on the UAHPC, and your PI needs to add you to their group. So you need to request your PI to add you to their group on the HPC. And once the PI has added the student, then they can use the HPC resources via the Linux terminal. So how do we use the Linux terminal to access the UAHPC resources? The first step is to enter the following in terminal window, which is sshnet@hpc.arizona.edu. So here I have provided my own example where I use my own net ID. Once you have done that, the terminal window will ask you to enter a password, which is the same password that you use to log into D2L and other university affiliated sites. So once you enter that password, then you have to do the usual authentication process where you choose duo push, phone, or SMS passcodes. And once you have done that, as you can see here in the photo in the bottom, the terminal window will ask you to type shell to access the job submission hosts for all environments. So basically, you just have to type shell. So that's the third step. And once you type shell, this gives you access to Puma. But let's say you want to change the cluster, you want to use another cluster like Ocelot or Elgato. So you need to simply type the name of your desired cluster, and then the cluster will change to Ocelot or Elgato. Now comes storage. So every PI's group has two folders. One is the group directory, and the second is the Xdisk directory. So group directory, the name of the group directory is the same as your PI's net ID, and it has 500 GB of permanent space that is shared between all the group members. Xdisk directory also has the PI's net ID as its name, and it has 20 terabytes, which is much higher than your group directory. And but this is shared temporary space, so it expires after every 6 months, after which your PI has to renew it. So once you log in, you are automatically transferred to your home directory on the HPC. And to access your PI's group directory, you need to type the command cd/group/PI's net ID. CD stands for change directory, so it's a command that is frequently used in the command line interface. And for accessing Xdisk, you need to type cd/xdisk/your PI's net ID. A very important note about Xdisk is that you have your own directory by default in the Xdisk with your net ID as its name, and you can only operate within that directory when you are in your PI's Xdisk. So if you are in your PI's Xdisk but outside your own directory, you cannot create new files, folders, or delete other files or folders. You will just simply get permission denied. So you have to be inside your own directory to operate within the Xdisk. The next step is how do we run a job on the UAHPC cluster? So I explained that here by providing an example of running a MATLAB script. So the first step would be to create a new directory in either your Xdisk directory or your PI's group directory. The sample command would be make dir MATLAB. So I'm naming my directory MATLAB. Make dir stands for make directory, another common command that is used in the command line interface. ls command is used to list all files inside a directory. So here, this is my directory inside my PS group directory. So ls will just show the two scripts that are present in my directory. Then I do make dir MATLAB. Then this new directory is created. And then the second step would be typing cd MATLAB in the command line. So you're entering the newly created directory. And third step, you need a script to execute. So you transfer a MATLAB script from your computer to your HPC folder. This transferring process is slightly involved, so I'll not go into the details of that process, but this website here explains the process pretty well. It's straightforward, it's slightly long. So because of time constraints, I'm not explaining it right now. Next, once you have transferred your script, you want to check whether it has actually been transferred to your folder. So you simply type ls, and here you can see the script, which is trial.m. Now we want to execute the script, and for that purpose, we create a submission script that we will use to submit our HPC job. So this is how the script looks. And you can just type all of this in a text file and upload that to your folder, in this case, MATLAB. So the first line lists the name of your job. In this case, it's sample job. Then n tasks is basically the number of processors that you want to use. Nodes is the number of nodes. So here I'm using one node and then 28 cores in that node. So I'm on Puma, where every node has 94 cores. So I'm using only 28 cores out of those 94. Next is time. So for how many hours you want your job to run? So here I'm only using 1 hour, but the limit is 240 hours. Partition, there are two types of partitions, windfall and standard. So the difference between the two is slightly involved, and I'll not go into the details of that, but you can find them on the UAHPC website. They have explained it pretty well. Following this, you have mail user and you have my email ID. So this is optional. If you do this, you will get an email when your job starts and also another email when your job ends. And then following this, we have the line module load MATLAB/version. So here we are specifying what version of MATLAB we want the cluster to load and use for executing our script. And the last line is MATLAB -node display -no splash trial.m output.txt. So this line executes our script trial.m and produces a file named output.txt. So this file contains all the information that would appear in the command window of MATLAB if you execute the script normally on your own computer using MATLAB. And before submitting this script, it is very, very important that we launch an interactive session, because the cluster needs this session to use MATLAB and other software. If you don't launch this session and just simply submit the script, your job will fail, at least for MATLAB. So you have to type interactive, and once you have entered an interactive session, then the cluster has access to MATLAB and it can use it to execute your script. So the final step is simply typing sbatch and the name of your job script. And once you do that, your job is done. So you have submitted your job, and then the status of the job can be viewed by using the QU command. You type this command. You can see here I have 3 jobs. The first one is my project related job. So it's using one node, 94 cores, running for 150 hours. So it's currently running. The second one is the interactive session that I canceled after submitting my job. And the third one is our sample job, where we are executing our MATLAB script. So it's using one node, 28 cores as specified earlier, to run for 1 hour, and it's currently in queue. And any output files that the job script produces are stored in the directory that contains the job script. And it is very important that your job script is in the same directory as the MATLAB script that you want to execute. And so with this, I'd like to end my presentation, and thank you for your attention. So I have provided a very brief and basic outline of how high performance computing at the University of Arizona works on the student side. And if you have any questions, please feel free to reach out.